All right, section 5.5, which is still applying the remainder and factor theorems. We're actually going to get into a couple of the theorems. So the first one, called the remainder theorem, says if you have a polynomial function, we'll just call it f of x, and you divide by x minus k, so that's a nice linear function with a leading coefficient of 1, then the remainder is whatever f of k is. So I'm going to show you an example here because that probably doesn't make a whole lot of sense, but let's just say that x minus k was x minus 2. Then I know that f of 2, whatever I would get when I evaluate that, is my remainder. And I think you'll see it when I do this example. Okay, so this one says to divide this cubic function by x plus 2. Now, the previous video did long division, but you're going to love this. Okay, so you can use synthetic division only when you're dividing by a linear function. Okay, so I am, right? I'm dividing by x plus 2, and that's linear. And the leading coefficient has to equal 1. And it is 1x plus 2. Okay, if it were 3x plus 2, then you can use synthetic, but it's a kind of a different process with interpreting your answers. So we're not going to go there yet. You will probably when you get to pre-calculus. So make yourself a note. This is so important. You can only use synthetic division when you're dividing by a linear function and the leading coefficient is 1. Okay, so we're good to go here. So I'm going to, you're familiar with the synthetic process, okay, so I'm going to do my little half box here. I have a 1, a 4, x squared, a negative 5x, and a 3, so I have everything from cubed, squared, x to the first, x to the 0. And I'm dividing by x plus 2, so what you do is you set whatever you're dividing by equal to 0, and you solve it. Well, that's obviously negative 2, and that's always what's going to go out front here. And then you do the synthetic process, and this you're familiar with. So you carry down 1, multiply 1 times negative 2, add 4 minus 2, multiply 2 times negative 2, add negative 5 minus 4, multiply by negative 2, and add. And this is your remainder. Okay, so that's what the remainder theorem says. Now, that is maybe a little more work than if I just did direct substitution. Okay, I just did synthetic. If I do direct substitution, what I'm going to do is, now go back up here, f of x, if it's divided by a linear function, then your remainder is going to be f of k. So if I have x minus k, and I had x plus 2, right, I am going to put negative 2, right, you always do the opposite sign, negative 2 into this function. Okay, so if I do that, I'm just going to show you here, I would have negative 2 cubed plus 4 times negative 2 squared minus 5 times negative 2, and then plus 3. And if we simplify, negative 2 cubed is negative 8, negative 2 squared is 4, times 4 is 16, negative times negative is a plus 10, and negative 8 plus 16 is 8, 8 plus 10 is 18, and 18 plus 3 is 21. Now you're probably saying, all right, direct substitution was a lot easier, and I agree, or maybe not easier, but it could be quicker. But you will have to verify these using synthetic division, and actually you're going to appreciate this process, I promise you, very soon. All right, the other theorem is called the factor theorem, which says a polynomial function f of x has a factor x minus k if and only if f of k equals 0. So I'm going to reference the previous slide where we did f of negative 2, I believe, right? And we got a remainder of like 21. Well, if it doesn't equal 0, then I know that that was not a factor. So for example, if I did long division and I got a remainder, then I know that that polynomial function is not factorable with one of these factors. You'll see that this will be real helpful later. So let me show you an example of the factor theorem. It says to factor this cubic completely given that x minus 3 is a factor. Okay, so I know that this cubic is going to have 3 factors because it's cubed, and x minus 3 is one of them, so I have to find the other 2. Okay, so I also know because it's a factor that if I do synthetic division, I should get a 0 remainder. Okay, so here's the process. You take coefficients, and you're familiar with synthetic division, so that's your first step, is to do synthetic division with this. Okay, so I'm going to take 2x cubed minus 11x squared plus 3x plus 36, and I'm dividing by x minus 3, so remember you set that equal to 0, so I'm really going to divide by 3 out front. Okay, so carry down, multiply, add, add, and multiply, and of course I get a 0 remainder, and I should because I was told that it is a factor up here. Okay, so now if you think about when you do long division, when you take x cubed divided by x, you're automatically going to be down to a quadratic, right? Because x cubed divided by x is x squared. The same thing happens here. How cool is that? So this is really 2x squared minus 5x minus 12. And with no remainder, I can now take this quadratic and just factor it down. So depending on the method of factoring that you prefer, you know, if you do the FIFO method or guess and check, you know, pause the video, make sure that you can factor, but I'm assuming you can factor from last chapter. And this will be minus, oops, wrong here, minus 4 and plus 3. And my factor that was given was x minus 3, so I'm going to squeeze that in here, and that's your final answer. And I'll tell you, a lot of times people forget to write that factor down just because it was given, but it does say to factor the cubic completely, so it's these 2 and then of course the one that was given. So again, that's a really cool process, a cool way to factor this cubic like we've never done before. Of course you have to be given a factor to do that. Okay, so last example, kind of tying all this together, and pause the video, see if you can figure this out. But it says 1, 0 for f of x with the following function is x equals negative 1. So I know that that's a 0. So what does a 0 mean? That means that it's a solution, an x-intercept. That also means that x plus 1 would be a factor, right? Because if I solved x plus 1, I'd get negative 1, and I know that that's going to give me a 0 remainder. So hence, knowing that, I'm going to take that cubic function, take the coefficients, and again, I have everything I need, and I'm going to divide by negative 1 because that is the solution, so I don't have to reverse the factor. And I'm going to do that process here. And I get a 0 remainder, which is good, and I knew that because I was told it was a 0, so it should be a 0 remainder. So then, again, I went from a cubic, and I divided by a first degree, so I should be down to a quadratic, which I just think is so cool. So here I am with this quadratic, and that will factor down. That's a nice, easy one. And I want to find the zeros. Now the previous one I just wanted to factor, so I would have been done here while I would have tossed down this other factor, but now I want the zeros. So I set each of them equal to 0. You're familiar with this process also. And you get negative 6, and you get positive 3, and then of course negative 1 was given, but they did say to find the others, so that is good.